Hello, so let's start solving the question. And question says that a stream of electrons from a heated filament, right, was passed between two charged plates kept at a potential difference V, right, ESU. If E and M are the charge and mass of the electron respectively, right, so find the value of H by lambda, right. We have to calculate the value of H by lambda, right, where lambda is a wavelength associated with the electron wave, right, is given by. So here the four options. So let's start solving this question. So we know that a stream of electron from a heated filament was passed, right? That means we can say that the kinetic energy of electron. That means I can write it here as the kinetic energy, right? Kinetic energy of an electron is equals to, if you can say that 1 by 2 mu square, right? 1 by 2 mu square, right? We know that the kinetic energy equals to 1 by 2 mu square, right? U is the velocity of electron, right? Here U is the velocity of electron. I am just taking to differentiate because V is a potential difference, and we know that potential difference. So you can say that the kinetic energy also equals to kinetic energy, or you can say that the energy of an electron. You can say that the energy of an electron is also equals to charge. That means E, right? So charge on the electron is E, right? So that charge into potential, right? Charge into potential V, right? That's why I taking here U, right? Because it is 1 by 2 mv square, right? So just to differentiate it, I'm taking here U, right? So it is charge into potential is equals to energy, right? So we know that from the equation 1, right? From the equation 1, I can see that from the equation 1 and from the equation 2, if I'm comparing it, I will get I will get E into V is equals to 1 by 2 mu square, right? 1 by 2 mu square, right? This is the value, or you can say, but we have to calculate the value of h by lambda, right? So we have to calculate the value of h by lambda, right? So I'm writing here, right? So we have to calculate the value of h by lambda, right? So uh, this is the value we have to calculate. So from here I can write it here, u is equals to, right, I can write here u square is equals to 2 EV, right, divide by m, right? So this is the value of u square, and from here I can clearly write as u is equal to the velocity of electron comes out to be under root 2 EV divided by m, right? So here we know that from the de Broglie relation, we know that lambda is equals to h upon mv, right? From the de Broglie relation, we know that the lambda is equal to h upon mv, and lambda is wavelength, right? So but we have to calculate the value of h by lambda, right? So we can say that the value of mv comes out to be h by lambda. Value of v comes out to be, or you can say, but here we have taken the velocity of electron is u, right? So I can take here, right? So I can take here u, right? So I can take here u, right? So it is not u, it is not u, it is v, right? So it is also, you can say that it is also u, not v, right? So this is u, because we have taken u is the velocity of electron, right? So the mu becomes h by lambda, right? So if I want to find out the value of h by lambda, just we have to calculate the value of mu, because it is equal to h by lambda. So automatically the value of h by lambda be calculated, right? So let's start it. So we have calculated the value of u, that means velocity of electron. Just put the value of u in this equation. We get the value of u. After putting the value, we get m into under root 2 E is the charge on the electron, V is the potential difference, and m is the mass of the electron, right? M is the mass of the electron, and it is equals to h by lambda, right? It is equals to h by lambda. So here I can write this in this form, right? H by lambda is equals to, I can write here under root 2 m, right? 2 m ev, right? 2 m is the mass of electron, and E is the charge over it, and V is the potential difference applied, right? So this is the value of h by lambda, right? This is the value of h by lambda. So let's check the option, and options are 2 mv, right? So 2 mv, option is 2 mv. No, this is not the right answer, right? This is not the right answer. Under root 2 mv ev, right? This is not the right answer, right? Because we get under root 2 mev. Yes, C is the right answer, right? C is the right answer, and D is also a wrong answer, right? So the value of h by lambda comes out to be under root 2 mev, right? Where m is mass of the electron, E is, you can say that the charge on the electron, and V is the you can see the potential difference, right? So hope this answered your question. So thank you.
Hey guys, क्वेश्चन यह है कि रदरफोर्ड्स एक्सपेरिमेंट विच एस्टैब्लिश द न्यूक्लियर मॉडल ऑफ एटम यूज्ड इन बीम होम। जो रदरफोर्ड का एक्सपेरिमेंट है जो कि हमारा उसका न्यूक्लियर मॉडल फेमस था, तो उसमें उन्होंने किसकी बीम यूज की थी। सो वी हैव फोर ऑप्शंस, लेट अस मार्क देम। ऑप्शन ए रीड्स दैट बीटा पार्टिकल्स विच इम्पैक्ट ऑन मेटल फॉइल एंड गेट एब्जॉर्ब। नहीं, ये गलत बात है। जो रदरफोर्ड का एक्सपेरिमेंट था उसमें क्या था, हमारे पास अल्फा पार्टिकल्स थे, इनको स्ट्राइक किया गया। एक मेटल फॉइल था, दिस इज द मेटल फॉइल, इन पे इनको स्ट्राइक किया गया और उसके बाद ये क्या करे, स्ट्राइक स्कैटर हो गए सारे के सारे। तो ये हमारे पास ऑब्जर्वेशन थी। तो ऑप्शन बी पढ़ते हैं। ऑप्शन बी कहता है कि गामा रेज नहीं। ऑप्शन सी रेट्स दैट हीलियम एटम्स, अल्फा पार्टिकल्स वो क्या होता है, वो हीलियम एटम्स, हीलियम के एटम्स नहीं, वो हीलियम के न्यूक्लियाई होते हैं। विच इम्पैक्ट ऑन मेटल फॉइल एंड गॉट स्कैटर, नहीं, दे वरंट helium atoms, it would be appropriate to say helium nuclei instead of helium atoms. ऑप्शन डी कहता है कि हीलियम न्यूक्लियाई विच इम्पीज्ड ऑन द मेटल फॉइल एंड गॉट स्कैटर्ड। तो करेक्ट ऑप्शन कौन सा होगा, ऑप्शन डी, एंड दैट विल बी द आंसर फॉर दिस क्वेश्चन।
Hello students, the question is Rutherford's alpha particle scattering experiment was led to the conclusion that mass and energy are related. Electrons occupy space around the nucleus. Neutrons are burned deep inside the nucleus. The point of impact with matter can be precisely determined. So first let us discuss Rutherford's alpha scattering experiment. So Rutherford alpha scattering experiment. So in this experiment, a source was taken which emitted alpha particles, and this alpha particle would strike on a thin gold foil, and a circular fluorescent screen of zinc sulfide was placed here. Now what happened is, whenever alpha particle struck this zinc sulfide screen, then flash of light appeared. So the observations were most of alpha particle pass through gold foil. The second one is small fraction of alpha particle deflected by small angle. Small fraction of alpha particle were deflected by small angle. And the third observation was very few deflected by nearly 180 degree. Very few deflected by 180 degree. As you can see here, very few deflected by 180 degree like this, and some of the gold foils were deflected by small angle and most of it passed through this. We can see here. Now the conclusions that were made were, most of the space inside is empty. Most of space is empty, as you can see here, and so most of the space inside this is empty, as most of the alpha particles pass through this without being deflected. So the next one is, few were deflected, few alpha rays were deflected, indicating that a repulsive force is present which is not concentrated over the whole area, rather it is concentrated over the small area, and this is termed as nucleus. So this is nucleus. And the last one is, volume occupied by the nucleus is very small as compared to the total volume of the atom. Volume occupied by nucleus is very less as compared to volume occupied by atom. Now by these observations and by these conclusions, Rutherford model were made and the postulates are, so Rutherford model. According to this, positive charge resides over a mass in a small region, and this small region is called nucleus. Electrons revolve around, nucleus is surrounded by electrons which revolve in circular paths called orbits. And the third one is there is electrostatic force of attraction between positively charged nucleus and the electrons in the circular path. So the question was, Rutherford alpha particle scattering experiment led to the conclusion that mass and energy are related. We have not seen any mass and energy relation in this Rutherford alpha scattering experiment. Electrons occupy space around the nucleus. Yes, this was the second postulate which said that if the nucleus is present here, considering, then the electrons will revolve around in circular path, and these paths are called orbits. Neutrons are bumped deep inside the nucleus. There is nothing said about neutrons here. The point of impact with matter can be precisely determined. So this is also false. So the only correct statement is electrons occupy around the nucleus. Electrons occupy space around the nucleus. Thank you.
Question: the radius of an atomic nucleus is of the order of. तो ये हमें याद करने वाला है कि रेडियस ऑफ न्यूक्लियस क्या होता है, किसके ऑर्डर का होता है. रेडियस का जो ऑर्डर है वो होता है 10⁻13 सेंटीमीटर. हमें ये याद रखना है. ये है. तो इसके तहत जो ऑप्शन हो जाएगा मेरा बी ऑप्शन करेक्ट ऑप्शन हो जाएगा.